Okay, my friends, it's Roger, Mudfossil University. We've got PBS Digital here talking about light. Now, I'm going to run this for a little short bit here, and then when they come to the point where I figure that they're not going to be right anymore and it's not worth watching, I will stop and then I will show you why I say it's not going to be right and it's not worth watching. So here goes.
Hey, Phil Plait here, and this is Crash Course Astronomy. In last week's episode, I mentioned that nearly all the information we have about the universe comes in the form of light. But how does that light get made? What can it tell us about these astronomical objects? And honestly, what is light?
All right, first of all, remember he said everything we know comes from what we know about light. And now he's going to explain what he has to say about light. So here it goes.
Here's a hint.
One giant leap for the human mind. All right, now we're going to see if we can shed light on light.
Light is a wave. It took centuries of thought and experiments to figure that out.
All right, it's over. Now, let me show you. So everything he says from now on is incorrect because he's based it on that obvious incorrect statement. And this is why it's incorrect. Okay, now I'm going to explain to you, my good friends, why the statement that light is a wave is totally incorrect, and I can prove it right now. This is light, and that is a wave. I have no problem accepting that this looks like a wave. However, the truth of the matter is there is a tiny little particle right there concussing everything as it moves through the air from this pulsed red laser. All these little tiny particles in the air, this is right in the middle of the air, those are ether particles. And what is ether particles? They are free extra electrons that are not bound necessarily strongly to particles, and they are more or less static. They would collect on you when you walk through the air. Basically, they're attached to water molecules primarily. Water molecules are extremely polar. H2O. Anyway, so that's what those are, ether. This is a particle creating a concussive wave around it, and let's see why I can make that statement. Now, this is an extremely interesting shot. Now, these pictures were taken by Rodney Warren in Australia. I work with Rodney Warren. I have the same setup he has. I have the same lasers and everything. Very, very sophisticated system, which I will show you momentarily. And but he was much more proficient, and these are his pictures. And he was the one that discovered the venturi. Quite by accident, I was the one that realized what he had done because it fit into my atomic theory just absolutely fabulously, and it fits into understanding the true nature of particles and particle physics. This is that pulsed red laser. What happened here? All of a sudden we're seeing the particle itself break away from its concussive wave and elongate that concussive wave, rip it through, and then escape from it. And then, because it's piling against its friends in front of it, concussing, this is what you have here. Hold on a second. I got a little thing to show you, I think. I do not. What we have here is two metal drums, one here and one here. And they're drums, they stick up off like this. The light is shining through between those drums, and because there's a curved surface here and a curved surface here, it explodes in the middle and has to excite. That is a venturi. Venturi. Now, because those particles, although we see them as tiny, tiny, tiny little white dots, let me expand this a little bit. You see that? we see these particles as tiny, tiny, tiny little white dots. Well, that is not the case. Those tiny, tiny, tiny little white dots own huge regions like this. Huge, just gigantic, absolutely enormous regions. However, the particle that exists in the center of them is that tiny particle. Now, you can see it goes this way. It's going like crazy. You see all the same stuff we had before, all the little ether. But what happened this time? This time, the wave goes this way, zoom, 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 and boom, and then it comes back this way. You see this? You see that concussive? That's what's called reverse electromotive force. Electro means electricity, motive means moving, force means moving forcefully. It is the reaction in this concussive area and making these things glow. They're not glowing coming this way, they're glowing coming back. And you can see them back way over here. You see this? This is exciting stuff to me. It's very exciting. Now, so we have seen the wave, which we're going to call it, but it's turned into a particle. And then we saw the concussion, which is the acceleration. We know it accelerated. There's the concussion. There's the plasma. There is the emissive particles, which they would always call that interference patterns, thinking that they're waves and they're flapping against each other. This is a single slit venturi. There is no such thing as wavy particles, or as waves. They are particles spinning, and I will show you that. Hold on, let me get the simulator, which is this. Now, as it spins through the air, it is a wave. You could see it. It goes up and down, up and down, up and down. That's a wave. But if you looked at it from the front, it's spinning at you in a right-hand spin, coming at you. So that's what's happening, and I can prove that as well. Anybody with any technical ability whatsoever can see that this is spinning, and it is not only spinning, it is accumulating in regions which seem to take little spaces. Why is that? This is the particle. It's coming through the accelerator, spinning, and then some spin this way, some spin over this way, most spin through the center. That's why you get these interference patterns. That is literally turning it, you can see it, right through. All right, a friend sent me this, and I thought, wow, this is amazing. Somebody figured this out. One electron universe. Whoa. And this is from PBS, Public Broadcasting. This guy got the Nobel Prize for this, and I'm thinking, oh, this is fabulous. I didn't know anybody knew this. Well, listen to this.
The fateful conversation began. Feynman, I know why all electrons have the same charge and the same mass.
All right, here's the key. Here's why they were trying to figure out, why is every electron identical? Okay, why is it exactly the same mass, the same charge? Every single one that they see. He says, I know why.
Asked Wheeler's former graduate students. Because they are all the same electron.
Now, he literally means that there's one electron in the universe. Not the one electron universe. That's what he means. Not that there's a bunch of them and they're all the same. He means there's only one that makes the entire universe. I don't know what it's to say. When I saw that, I said, I think I got a Nobel Prize. He got a Nobel Prize. And anyway, if you want to watch this, and I don't know what to say. I'm not saying anymore. All right, to save a little bit of time here, that's what we had. There's the wave coming through. There's the accelerated wave. There's the particle. There's the plasma. There's the interference pattern. There's the ether. These are Higgs fields. That is Cherenkov radiation creating bosons, which are charged particles carrying fields. And they just follow that charged particle as it goes. And that is the charged particle spinning to the right, means it will drift to the left. Expanded here, contracted there, means it's slowing down. That is the actual particle. You see that black and white, or it's red and white, upside down, and in other words, they're back to back. There's one, they're like this. And one's this way, just like two bar magnets stuck together. That's a photon. If you smash that apart, you're going to end up with electrons. Simple as that. That came in as a photon, smashed it to bits as particles, came back together as a photon. They want to be together. They don't want to be bar magnets just floating around in space, a bar magnet. No, it's going to attach to something. Now, bar magnets do that. Now, this was a very unusual event in that up here a white particle came through here, which I believe was a reverse spinner, which is for all practical effect antimatter, because it's reverse spinning. It's the same size, same weight, same particle, same source, only it's backwards. What is that? I mean, it sounds like antimatter to me. And there it is. It has a structure. It crashed into one of these waves or fields or whatever you want to call them, and it emitted this, which is a mini one of those. It may grow, it may stay there. I don't know what it's going to do. But these are the particles. This is fantastic. Now, they come out, first of all, with these spikes with some kind of radiation slamming into what is in front of it, and then they start to collapse. And then they eventually end up turning into like they look like little Oreo cookies almost. Now this is really focused in here. Remember how the wave was over here, the wave, and then it accelerated, and these are the tiny particles. Now, you see here you have white, but you have black here too. You see the little black spots? This I haven't really figured out yet, but you can see them. They're not going to be able to stay amongst the plasma. There's some form of, well, we know they came in black and white, or red and white. And then they did this, so there's the darkness, and then there's the whiteness, and then they came back over here, back into the darkness again, along into the whiteness. So in this section here, there is zero, absolute zero darkness. Darkness, nada. Je darkness there, none, zero. So why? What is separating? What is separating? And look at that. One here, one there. They're just like almost perfect dots. Very, very interesting recombination. But there's obviously something was here, had the ability to be black and white here, and ability to be black and white back here, and not here. Some of them way out on the sides that didn't have this absolute devastating impact on each other. In here, there's particles there that absolutely are so upset because everybody is crowded around them. They don't want that. They're glowing. Get the hell away from me. And that is what this does here. As it comes out of here, this is repelling because they don't want to be next to each other. It's not repelling, it's screwing through there, but it's not really. See how they try to get away from each other as far as they can? They set up these stripes and patterns. So I'm saying that light is obviously not a wave. It's obviously a particle. It obviously can accelerate. It obviously can turn into plasma. It obviously has some form of charge separation. And I can tell you one thing right now. If you can charge separate heavy hydrogens and blow them into little pieces where there's nothing but Cherenkov, and then they come out the other side, they will turn into helium. That is the story. And at that point, you will harvest a ton of extra particles. Now, what do you have to put into it here? Nothing, not a thing. Nothing, zero. This is a passive device. It is a crusher because it's really a waveguide crusher venturi. So if this was all in a vacuum chamber and you were shooting heavy particles in there and they came out over here and you had an electrode over here that would pick up, because these are electrons when they come out of here, they're electrons. Right at this point, you should be able to harvest electrons right out of here, because that right there is electrons. That is not anything but electrons. The ones that were going this way are electrons. The ones that were on the other direction, upside down, they're separated from those, so they're electrons too. They may be floating in who knows what they're doing. Because hey, I'll show you what they look like when they come through. All right, this is the particles as they come out of the accelerator in absolute Cherenkov glowy radiation. This is just before they start to turn into the Higgs. I believe the Higgs fields start right about here, and then they drift back into their redness, which is their original particle. So they've been accelerated, they're slowing down, and they're returning to what they were. That's what I'm seeing. All right, before I talked about that white particle, there it is right there. They're spinning to the right. Now we're seeing them sort of sideways, but they're particles that are spinning to the right, and they are the electrons that are in the ether are following that particle. That's why you see these disks. They're literally following the spinning particle. Well, this one is not spinning to the right. This one is spinning to the left. And what does that mean? It gathers. It pulls the field into itself, into a glow. Now, that's what I'm seeing. And that, to me, is antimatter, because the other ones came from the same source. They came to the same venturi. They are emitted the same way. They came through the same spray of particles, only this one came out backwards. I don't know what that means to you. I see it as possible antimatter. All right, in addition to all of that, you asked something about electron neutrino. Oh, we can't find them. Well, they're electron neutrinos, which is an electron shower, and it occurs because of a high voltage electron, which is our accelerated electron, crashing into atmosphere that is not accelerated and creating electron showers. Cherenkov radiation from electron showers produced by electron neutrino events produces multiple cones, a diffuse ring in a detector array. Obviously seen that in my experiments. All right, these are CERN's Higgs events, they call them. Well, they're hitting head-on things. They're not focusing it. They're not doing anything like we are at all. They're using gigantic particles that are 8,000 times bigger than the particles we're using. So what do? They get a bunch of slam it into a bunch of particles everywhere, and then they go digging through them. But you can see all the same exact patterns, the circles and spins, and I'll show you another one. All right. My statement is that there's only one particle in the universe, and it adds everything together and turns into protons and neutrons and atoms and molecules and people and planets. And they are all made from one single dipole particle. All right? They have 8,000. They slam them together head to head, and they just splash them all over the place. But they're the same looking things. They're the same things, only they're just gigantic. Now, we have the ones that are like these over here. You can't see them, but they're there. And we have, that's all we're using. We're not slamming gigantic chunks of things together. We don't need this kind of gigantic equipment. And as a matter of fact, I told you we have some extremely sophisticated equipment Rod and I were using to do these experiments, and I'll show it to you right now. Here they are. These are about, I don't know, 20 bucks a piece or something. That thing there is a Bosch GLM-15 construction laser. It pulses, bip, 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 red laser. And then it comes back and it reads it and says how many feet or inches or whatever. Rod had a metric one. I have an American one. But you just shoot it like that and you shoot the rays. And that was what he was shooting through the venturi. And he was creating these fabulous, fabulous results. And when I saw, and nobody understood what he was doing, and he had them on, I used putting them all up on the internet on this one particular group that I happened to just focused in on one day for just, and I think it was the name of the group was Focus or something. I can't remember. It's been a long time. This goes back over 4 years. I think that was the name of the group. But anyway, his pictures were up there. I saw them, and blew me right out of the water because I knew what I wanted to see. I could just never figure a way to get to see it, but Rod figured it out. And when I saw it, I went to my knees. I'm not kidding you, man. I just said, whoa. And I've been saying whoa ever since, because until they start looking at this work that Rod did, they're never going to get it right. I don't care. You could come up with every. Look at that. I mean, it's absolutely stunning. That's the light coming out. That's the light particle. It's spinning, creating these Higgs fields, and all of this ether is highly obviously seen. The thing that they say there is no ether, and all of that is the light coming down from the sun. Where do you think that light comes from? It comes from the sun. How do you think it gets here? It comes through space, which they say there's nothing there. That's where the dark energy and the dark matter is. That's where these things are until they come here. When they come here, they impact into our magnetosphere and our ionosphere, which the magnetosphere is 56,000 degrees out there. Why would it be so hot out there? Why wouldn't it be cold? It's hotter than hell. And it's 80 degrees down here. Well, the reason is it's being impacted by our spinning Earth, which carries a whole slew of its own electrons, slippering through that space that we are crashing into. And I will show you that right now. All right, this virtually proves what I'm saying. This is the sun moving through the arm of the galaxy, and it spins around the galaxy, dragged through a bazillion miles an hour. Now, what are we seeing here? We're seeing a wave. Well, what is that wave? We noticed it's spinning. You see that circle spin? It's spinning. Why is it spinning? And we're seeing a wave because it's spinning, but when you look at it from the side, it is a wave. Okay, this is a couple of cycles. This is just a very long wave. It goes woo, but it's doing this. Woo. Now, what are we doing? We are going around the sun this way as everything's going through the galaxy. This is the key. We are impacting in strange ways. There's your solstices. Winter solstice, summer solstice. These are equinoxes, spring and winter, or fall. Now, then you've got the angle of the elliptical pole of the sun, and then you've got the angle of the magnetic pole and the normal pole, the celestial pole, and then the magnetic pole is different. All right, now, then you've got the moon going around Earth. The Earth is going in this, and everything's going around, and I'm going to show you another shot that gives you another perspective of how this is impacting the region of space that's in front of it. And let's talk about that region of space, because what if that region of space was like this region of space instead of this region of space? What if it was dense like that? And we were coming into that. Well, what do you got then? Well, you're going to impact? Obviously going to impact hard. So we may be entering dense space. I say we are overloaded. I'm almost 100% sure of that, because the Earth will accept electrons. They do not leave the Earth the way they come to Earth. We suck them in. They don't spit out the way they get sucked in. They turn into plants. They turn into all kinds of things. They turn into the ionosphere. That's the source we're having of sprites right now, and it's the source of all kinds of magnetic anomalies, weather patterns, the shifting pole, magnetic pole. All kinds of things are a consequence of impacting particles light sometimes, dense sometimes. I don't know. It's a dance. It's a slamming into something, if it's stronger or weaker. How long did we do that? How much collected? Are we a capacitor? Have we reached our capacitance? Have we charged to where we need to discharge? And how would we discharge? All right, this is a big question, a serious question. But I'm going to tell you right now, what they think about light is absolutely wrong. It's not right whatsoever. And I think I've made my case. And if somebody can say that, because we're working with light, we're not working with heavy particles and seeing a whole bunch of stuff and saying, oh, this must be light. No, we're looking at light and saying, well, that's what light happens. What happens when you force light to crush into itself. And we could possibly do cold fusion with this. You know, I've been saying this for years, and you cannot patent something after it's been said for a year and a half. Because I made this public knowledge years ago about the fusion and about some other things. And I talked to a patent attorney, and he said, don't worry about it. Nobody can patent it once you say that stuff. And you have people knowing about it for a year and a half, cases closed on that for patents. So, whatever I talk about, really, I've been talking about for years. Nobody's paid any attention. So, as far as I'm concerned, nothing that I say you can patent. And if I, you know, that venturi and all that stuff, that was 4 or 5 years ago. And anyway, that's Rod's doing. He came up with that just because he was a guy looking to try to understand things. He didn't want to shoot anything to the moon, I don't think. And anyway, that's the way it works, and that's all I'm trying to do. I'm never going to make a penny at this. I don't want it. I got everything I need. I'm not rich, but I just don't need a lot. So take it for what it's worth. We are not thinking correctly. I'm going to leave it at that. But it's don't if you keep trying to make up stories based on dogma that isn't right, just all you are is a good storyteller.